Okay, my name's Tom Morris. You guys all know that. But my focus for this whole semester was to refine my design for a fixed heliotropic hot water heater. Now, the way I've been able to do this is throughout the semester I refined the design concept using the Reddick program that some of you are familiar with in another class, the best construction practices that we've learned out on the site, and focusing the 1-minute presentation on materials and processes that will help me make this test site the most energy efficient that I possibly can. The north elevation of the containment, as you can see.
A passive solar hot water heater, a painting studio using natural light, and a guest suite that would be compliant with the American Disabilities Act. I used Autodesk's Rivet 2018 to provide the graphics for these presentations. The concept team was able to engage professionals in solving the challenges associated with the unique construction process. This project brought together aspects of 4 construction management courses at Snow College. The combination of disciplines helped refine the design concept for the test site. Other influences included architectural relationships, practical aesthetics, and symmetry. This graphic shows the addition of a 2-foot insulated foundation skirt separating the test site with the connected geothermal greenhouse. The use of this material will cut cement construction costs and improve the year-round heating stability of
each facet is 60 degrees on each side and 8 feet tall, so you can imagine that that would be quite an interesting problem to solve with the construction process. But by using the panels themselves with the vacuum forming, then we're able to also create a faceted side, which would gain solar gain even more. And what we hope to do is, when we build the test site, to have measurements in every way we can. Ambient air coming in, ambient air inside the test facility, temperatures inside each containment to see if it actually does heat the hot water efficiently, and then also the solar gain.
So to provide a consistent year-round temperature within the test site. As we do this and gather the data for over a year, we should be able to determine and limit mechanical means for heating and cooling. If successful, the operating costs of the test site would be beneficial for future energy efficient design concepts. Some of these experimental concepts are the use of multiple layers of positive pressure cells made with silicone-coated ripstop nylon and ram air Dacron material. This material is the same thing that was used in sails for sailboats. The ram air philosophy is something that was designed in modern parachutes that allows the rigidity of the system to be maintained, but also limiting the weight and adding the translucence then of the Dacron material. These sail-like structures will be tied down with internal guy wires that are used. It was originally designed for engineering of high-voltage power lines. Where weight is a consideration, the 60-degree sloped walls and glazing of the solar containments will be a flexible plastic made with European diffused lighting material in conjunction with tailored vacuum-formed acrylic panels that focus the available energy to solar collectors inside the center of each containment cell. In addition to the subsurface installation, the test site would be heated and cooled using a passive geothermal system and radiant heat piping working together to maintain energy efficiency of the structure. The use of lightweight construction materials will further reduce costs and provide an installation capacity that can be measured and reproduced in similar construction projects. Each cell is supported by the 2 other cells, similar to the 3-legged stool that would add stability for the system in high winds. The copper hot water pipes that are fashioned in this way would be like wings of an aircraft. What gives the aircraft wing its strength is the outer surface. In similar ways, the Dacron material stretched over the copper piping would be the strength of the containments. This would also reduce the weight and add the flexibility as the sun goes through its arc. You would be able to flex a little bit to gain that solar energy. Distributing the weight in this fashion would also allow the system to store and heat up to 42 gallons of hot water and produce the energy for heating the structure itself. The other thing that this system would provide is natural sunlight into the system for a holistic, healthy environment and for an active residential lifestyle. Again, my name is Tom Morris. I'm from Utah. Thank you.